The history of the space program is very impressive. Since its beginnings in 1958, NASA has grown to be one of the most revolutionary agencies in recorded history. With President Kennedy's goal to reach the moon by the end of the 1960s,
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
and with the backing of the American public, technologies that would have seemed impossible in earlier years were being developed and perfected in record time. This drive and determination has never left the agency. Today, a new generation of researchers are gearing up for the next big step: crewed missions back to the moon, to Mars, and beyond. However, major challenges await. Questions of crew safety, medical concerns, the need for new technology development, and a host of other issues make this goal very daunting. To lead the way, robotic missions are being planned that can give researchers a better idea of what human crews can expect in space. I spoke with Mark Saunders at NASA Langley Research Center to help us understand how these robotic missions will work.
Our robotic missions are actually precursors to what it is that we're trying to accomplish with humans. They're the probes that we're sending out to help us understand what it is that we're getting to when we send people there. They're testing new systems, collecting data about what's actually happening on the planet's surface as well as the atmospheres. We want to make sure that we understand this to the maximum extent so that we're always sending humans in a safe way.
So Mark, what is the definition of a robotic mission?
People think of robots in many different ways, and those of us in the agency actually do that as well. We're making spacecraft. You know, as an example, the Hubble Space Telescope is a robotic spacecraft. It's actually very smart, but we talk to it a lot with people on the ground that kind of tell it what to do on a periodic basis, usually in terms of minutes. But as you get robots that are going farther out into the solar system, they need to really operate a lot on their own because it takes a long time for us to talk to them. So radio waves go out there and it's hours before we hear back from them. So they're actually operating pretty much by themselves.
What can we expect from robotic missions in the next few years?
As all of us have been watching, the Mars exploration rovers have been doing a great job on Mars. Cassini is at Saturn with its Huygens probe. We're planning the next series of missions, both for scientific purposes as well as to prepare us to send people on to the moon and then on to Mars.
The first of these planned robotic missions will be going back to the moon. The goal is to have these robots pave the way for humans by mapping the lunar surface, surveying potential landing sites, and searching for water ice. Now, tapping into water ice could be very important because human explorers could not only convert it into oxygen and hydrogen for breathing, but they could also use the gases to produce rocket propellant for future missions to Mars. In short, these robotic missions will allow NASA planners to design the needed equipment for astronauts to live and work on the moon, while also helping them prepare for future missions to Mars.
One of our biggest concerns is always making sure that our missions are as reasonably safe as possible for the human, as the human participates in it. So when we send out robotic missions to the moon and to Mars, we're trying to understand what the moon and Mars represent in terms of their environmental conditions, what they're made of, are there any elements there both in the atmosphere on Mars or on the surface of the moon that might have some toxic properties, and as well as their physical characteristics, their composition, so that we understand when we build a human spacecraft to go with humans in it, that the system that we send is compatible with the environment that it's going to be in. So that's one major point. The second point is that like the explorers of old, to the degree that we can use resources that we find, we want to be able to use those resources to help sustain them. And doing this, by the way, reduces the cost. So although it may cost us some to develop the technologies now, when we go, if they don't have to take stuff, it's, we don't have to pay to get it off the surface, and we're not paying to get water off the surface if we can find water there.
So is most of the technology already developed?
Technology is actually the key to what it is that we're trying to do. New technologies will enable us to be more efficient in how we go, allow us to actually take lighter weight systems, cheaper systems, more reliable, safer systems, so that the overall cost to the American taxpayer is dramatically less than the Apollo program.
And we've discussed going to the moon, going to Mars. What other destinations do you foresee for robotic missions?
Obviously, asteroids. And everybody's familiar with asteroids. We certainly have quite a few disaster movies around them. But there are a lot of scientists and engineers who believe that asteroids have the potential for resources that we might actually mine and use. And so one other destination are asteroids. What our strategy is to begin to make small steps towards the moon, to Mars, and then on to destinations beyond that. So we're going to gradually, over the next decades, push our human exploration beyond the boundaries as our robotic explorers find out new things about what's interesting out there.